Welcome to Podcast Lesson 2-2 Logic. This is the PowerPoint from the geometry website looking at Venn diagrams. Venn diagrams show relationships between sets of data, conditional statements. As you can read, we draw circles, sometimes ovals. For example, A is a poodle, an example of a dog. B is a horse. Therefore, we can write this statement: if you are a horse, then you are not a dog. If you're outside the set, then you're not inside the set. The word all right angles are congruent. Consider this an if-then form. If it's a right angle, then it is congruent. Same idea. We can write it in this sort of Venn diagram. All of the possible congruent angles in the world, right angles are just a subset of that. So it's about sets and subsets. If the sentence is true, then we can take the conclusion as the bigger set. The hypothesis is just one way of getting to the bigger set. Another example, the word every. Every rose is a flower. This one probably the easier to understand because we see the set flower and roses as a smaller set of that. So again, the bigger set is flowers, the smaller set is the rose. Or if it's already in the if-then form, like lines that are parallel, they do not intersect. Lots of lines do not intersect. Some of them are parallel. Asking yourself, how is that possible? To have other lines that do not intersect that aren't parallel? Wait for lesson 2-3. So, to look at relationships between sets that might not be inside but overlapping, such as this. When the PowerPoint says brown area, they mean this region right inside. So let me just break all this out here, right here. And so I can color it brown. Well, it's not going to be brown. Let's just call it black for now and call it brown. The dark area in the middle. This region, black. The black area is purple. Okay, looks blue to me. Is purple and yellow. So if you signify, how can you be in P, set P purple and set Y yellow? You'd be right in here. If you are not in the yellow set, one example would be the red set. I guess actually you could be outside. But tilde Y would be somewhere outside the yellow set. But if you wanted to be in purple or the yellow set, it doesn't mean just to be here or in here. It actually means anywhere inside. If you put your pencil down anywhere inside, you are in the purple or you're in the yellow set. So this particular statement, P or Y, would be all of this. Just as a note, you might remember from algebra class things like this. Maybe not. This kind of symbol. Anyone? Union. The union of P and Y means all of it. The intersection of P and Y is just the center, just the overlap. The logic side of this lesson, drawing and supporting conclusions. There are two particular laws of logic, and they're somewhat common sense, so very strange words for some very common sense ideas. If you're given some true conditional statement, and the hypothesis occurs, then the conclusion will happen. Here's another example one you've already heard. Suppose it's true that I make the statement, if I find $20 in the street, then I'll take you to the movies. This is true. If this is true, then every single time I find $20 in the street, I'm going to take you to the movies. That would have to happen for this to be a true statement. So say on October 10th, I find $20 in the street. Logic would tell us, I'm going to go take you to the movies. That is what we call law of detachment. Law of syllogism was more of a connecting of statements, a series of statements. If you have two or more conditional statements, the conclusion of the, if you have two or more conditional statements and the conclusion of the first statement is the hypothesis or beginning of the second, then you can put them together with the beginning of the first statement to go to the end of the second statement. With symbols, that's a little bit easier. If some statement P goes to Q, but then that statement Q is leading to R, then we can conclude that the beginning P will lead to R. You may recall this as the transitive property. An example. If it rains today, then we will not go to a picnic. If it rains today, then we will not have a picnic. But the next sentence, if we do not have a picnic, we will not see our friends. So an example. It rains today is a statement that led to we will not have a picnic. But then that hypothesis, we will not have a picnic, leads us to another idea. We will not see our friends. So if yellow leads to blue and blue leads to green, then you would expect that yellow would lead us to green. We will not have... Whoops, that was supposed to be green. Give me green. We will not see our friends. This is what we call the law of syllogism.